JavaScript is a single-threaded programming language, yet everything we do on the web tends to be blocking or time-consuming, which means that asynchronous programming is an essential skill for any JavaScript developer. Today's video will focus primarily on the amazing syntactic sugar provided by async await, but before we can get there, we really need to understand things from the ground up, starting with the browser or Node.js event loop, callbacks, promises, and then finally async await. And we're going to do this without making a single joke about async or await. If you're new here, like and subscribe, and we'll be giving away another one-of-a-kind t-shirt with this video. All you have to do is leave a comment below, and we'll pick a random winner next week. In order to understand anything async, you really need to first understand the event loop.
This is it. I hope that clears up any questions you have.
I'm going to give you the general overview, but I highly recommend you watch this talk from Jake Archibald, which is the best explanation of the event loop that I've ever seen. Then after you're done watching that talk, you should check out Stephen Fluen's Demos with Angular channel, which just released a video about callbacks, which are one of the things that happen within the event loop. So what is the event loop, and what does it have to do with async await? Both the browser and Node.js are always running a single-threaded event loop to run your code. On the first go around, it will run all of your synchronous code, but it might also queue up asynchronous events to be called back later. You say, here's a function that I need to run, but first I need to go get some data from the network. The event loop says, okay, I'll keep doing my thing while you do your thing in a separate thread pool. Then at some point in the future, get data will finish and let the event loop know that it's ready to be called back. Now, this is where things get interesting. If it's a macro task, like a set timeout or set interval, it will be executed on the next event loop. But if it's a micro task, like a fulfilled promise, then it will be called back before the start of the next event loop. Let's look at the implications of this by writing some actual code. First, we will write a console log, which is synchronous. Then we'll throw in a set timeout, but give it a time delay of 0 milliseconds. Then we'll have a promise that resolves right away. And lastly, we will add another console log for one more synchronous line of code. So nothing here has any actual time delay, so intuitively I would think that each line of code would be executed one by one. But that's not how things work in the event loop. If we execute this code, you can see the first line gets logged right away because it's running on the main thread. Then if we run the second line, it's being queued for a future task. Then the promise is being queued to run in the microtask queue immediately after this current task. And finally, the last console log gets executed right away. So even though the set timeout callback was queued up before the promise still gets executed first because of the priority of the microtask queue. So now that you know how the event loop works, we can start looking at promises. First, I'll show you how a promise-based API might be consumed, and then we'll look at how we actually create our own promises from scratch. So Fetch is a browser-based API, but it's also available in Node via the Node Fetch library, and it allows us to hit an HTTP endpoint and have the response returned to us as a promise of the response. Fetching data from a remote server is always going to be async, so we can queue up the promise, then provide it with a callback to map it to JSON. The great thing about promises is that we can chain them together. Mapping to JSON is also a promise, so we can return that promise from the original then callback, and then in the next one we'll have the actual user data as a plain JavaScript object. If we go ahead and run this code, you'll see it runs our console log first, and then it retrieves the data from the API and console logs that afterwards. The great thing about promises is that you can catch all errors in the chain with a single function. We can do this by adding catch to the bottom of our promise chain, and it will handle errors that happen anywhere within our asynchronous code. If this code were callback based, we'd have to have a separate error handler for every single one of the asynchronous operations. So if an error is thrown anywhere in our code, it's going to bypass all of the future then callbacks and go straight to the catch callback. When you start creating promises, that's when you're more likely to screw things up. First, I'm setting up a log function so I can show you the elapsed time between each line of code. Up a while loop that loops a billion times arbitrarily. If we run this on the main thread, it's going to block all of the code from executing until the billion loops are done. So we'll do one console log, run our while loop, and then do another console log after that. And you can see it takes about 700 milliseconds to finish the while loop. Our script is essentially frozen until that while loop is complete. So let's go ahead and wrap this code in a promise so we can get it off the main thread and execute it as a micro task. This is one tricky little way you might screw things up. So we create a new promise, we add our code inside that promise, and then we have it resolve to that value when done. So you might think that because we're wrapping this in a promise that we're going to execute this off the main thread. But the actual creation of the promise and that big while loop is still happening on the main thread. It's only the resolving of the value that happens as a micro task. So the first synchronous line gets logged right away, And the second one should too, but there's still a 700 millisecond delay because that while loop is still blocking on the main thread. So to ensure that all of our synchronous code runs as fast as possible, we'll refactor our code once again to say promise resolve, then we'll run the while loop inside of that resolved promises callback. By putting this code inside of a resolved promise, we can be guaranteed that it will be executed after all of the synchronous code in the current macro task has completed. If we go ahead and run our script again, you can see we get our 2 console logs right away, and then finally the promise resolves after 700 milliseconds. So now that you know all that stuff, you should be in the clear to use async await responsibly. We already know that promises are a huge improvement over callbacks, but promises can still be really hard to read and follow, especially when you have a long chain of multiple asynchronous events. Async await really just boils down to syntactic sugar to make your asynchronous code read like synchronous code. First, let's look at the async part of the equation and see what that does. So here we have a regular function that does nothing, and if we put the async keyword in front of it, we have a function that returns a promise of nothing. So whatever gets returned inside this function will be a promise of that value. I'm going to reuse this getFruit function throughout the lesson just to simulate what a promise-based API looks like. In this case, the user can pass in the name of a fruit, and then the function will resolve to the value of the fruit emoji from this object. And just to make this a little more clear, if we didn't use the async keyword, we could write this function by just returning a promise that resolves to this value. So when you use the async keyword, the magic that happens is that it takes the return value and automatically resolves it as a promise. But that's not everything that it does. It also sets up a context for you to use the await keyword. The real power of an async function comes when you combine it with the await keyword to pause the execution of the function. Now I'm going to write a second async function called makeSmoothie. What we need to do is get multiple fruits and then combine them together as a single value. Instead of chaining together a bunch of then callbacks, we can just have a promise resolve to the value of a variable. Await is like saying pause the execution of this function until the getFruit promise resolves to a value, at which point we can use it as the variable a. And then we'll move on to the next line of code. After we get a pineapple, we can then get a strawberry, and then we'll return them together as an array. One of the most annoying things with promises is that it's kind of difficult to share resolved values between multiple steps in the promise chain. But async await solves this problem really nicely. The code on the right is what this would look like if we wrote it with just regular promises, and as you can see, there's a lot more code and a lot more complexity there. Now, if you're already a JavaScript expert, then I'm kind of trolling you because you know that the code on the left is making the single biggest mistake that people make when using async await, and that is failing to run the code concurrently. If we go back to the code on the left, you can see that we're waiting for a pineapple to resolve, and then we're getting a strawberry afterwards. But we could get both of these things at the same time. You really only need to await one thing after the other if the second value is dependent on the first value. For example, if you need to get a user ID before you can then retrieve some data from the database. Let's imagine we're making these calls from a remote API and there's about a second of latency. If we run this code again with a delay, you can see it takes a full second to get the first fruit and then a full second to get the second fruit. But the whole point of the event loop is to avoid blocking code like this. So we know that an async function always returns a promise. So instead of doing one after the other, we can add both of our promises to promise.all. This will tell all the promises in the array to run concurrently and then have the resolved values be at that index in the array. So this is something that you should always be thinking about when working with async functions. You don't want to accidentally pause a function unnecessarily. So instead of awaiting a whole bunch of individual promises, you might want to add all your promises to an array and then await that promise.all call. And as you can see here, we've doubled the speed of the original function. Another nice benefit of async await is error handling. Instead of chaining a catch callback to our promise chain, we can just wrap our code in a try-catch block. This offers much better flexibility when handling errors that might occur across multiple promises. If we take our code from the last example and throw an error in the middle of it, we can then catch that error down here in the catch block. The first thing we'll probably want to do here is console log the error, and then we can either catch the error and throw another error, or we can catch the error and return a value. Your decision here will dictate the control flow for the consumer of this promise. If you return a value, it's basically like ignoring the error and then providing some replacement value. So the consumer of the promise won't get an error, but instead they'll get the resolved value inside of the then callback. In contrast, if we throw an error inside of our catch block, it will break the consumer's promise chain and be handled by their catch callback. Now I want to show you a couple of tricks to make your code as sweet as possible. Let's imagine we have a string of IDs and then we want to retrieve all these IDs from the database. We can use array map to convert them to an array of promises and then resolve them all concurrently using promise.all. That looks great, but you need to be careful when using async await in a map or for each loop, because it won't actually pause the function in this context. So normally we would expect this loop to stop if we do await get fruit, but that's actually not what happens in this case. Instead, it will run all these promises concurrently, so that might not be the behavior that you're expecting. If you want to run a loop and have every iteration in that loop await a promise, you need to use a traditional for loop. So you can write async functions and then write a for loop inside that function and then use the await keyword inside the loop. When you write your code like this, it will pause each step of the loop until that promise is resolved. But more often than not, you'll probably want to run everything concurrently, and a cool thing you can do is use the await keyword directly in a for loop. If you have a promise that you know resolves to an array, you can actually just use the await keyword directly in your loop. So you can say for await in your code, which will await the array of items to resolve and then loop over them immediately after. And as you can probably imagine, you can also use the await keyword directly in your conditionals. On the left side of the conditional, we can await the resolved value from a promise, and then we can see if it's equal to some other value. So that gives you a super concise way to write conditional expressions when working with promises. Hopefully that gives you some ideas on what you can do with async await in ES7 or TypeScript. It is truly one of the sweetest things to ever happen to JavaScript. If this video helped you, please like and subscribe, and make sure to join the live stream next week for the t-shirt giveaway. And if you want to take your development to the next level, consider becoming a pro member at angularfirebase.com. You'll get access to all kinds of advanced content designed to help you build and ship your app faster. Thanks for watching, and I'll talk to you soon.